Hello everyone. So in this video lecture we will study the synchronous motor. The synchronous motor means the speed at which the rotor rotates at the synchronous speed that we call as a synchronous motor. That means the synchronous speed is what? The speed at which the rotating magnetic field is rotates that we call as a synchronous speed. So the rotating magnetic field and the rotor has the same speed. Means that rotor rotates at the same speed as the rotating magnetic field, which is called as the synchronous speed. So the rotor rotates at the synchronous speed. That motor we call as a synchronous motor. So a synchronous motor is a machine that converts AC electrical power to mechanical power at a constant speed. That is synchronous speed. We call as a synchronous speed. So synchronous motor is doubly excited machine because we give the supply, that is AC supply, to the stator winding and a DC supply to the rotor winding. So basically we give the two different types of supply or two excitation to create a two different magnetic field. So that we call as a doubly excited machine. So its rotor poles are excited by DC and its stator winding are connected to the AC supply. So like most rotating machines, a synchronous machine can also operate as both a generator and a motor, but with some modification. So construction of synchronous motor, that is, this is the stator frame, this is the stator part, and this is a called as a shaft. So we give a three-phase supply to the stator windings and DC supply to the rotor winding in order to produce a alternate N and S. So this diagram is a four-pole synchronous motor. That is, this is a four NS NS. So synchronous motor is a machine that operates at synchronous speed and converts electrical energy into mechanical energy. The construction of three-phase synchronous motor essentially same that of a synchronous generator. That is, it consists of a stator which consists of three-phase armature winding in the slots of stator core and receives power from three-phase AC supply. The stator is wound for the same number of poles as the rotor poles. And next one is rotor that has a set of silent pole or cylindrical pole. Silent moles means this cylindrical means only plain circular rotor, but silent means this is shape, that is this outer shape, that is this type of shape is called as the silent pole. So silent poles or cylindrical pole excited by DC current to form alternate N and S. So the exciting coils are connected in series to two slip rings and direct current is fed into the winding from the external exciter mounted on the rotor shaft. So principle of operation of synchronous motor. So in this diagram, the three phases are given. That is RYB, three phase AC supply is given to the stator winding, and DC excitation given to the rotor winding in order to produce alternate N and S pole. So this is diagram of two pole synchronous motor. That is two pole, that is N and S. So when we given the sub three phase supply to the stator winding, it creates a rotating magnetic field. So, if in first case, suppose we do not give a DC X to the rotor winding, so only we given the three phase AC supply. So this motor is act similar to the three phase induction motor. If after certain speed, after certain time, if we give a DC, then there is a creation of N and S. So this N and S pole, the stator also has a N and S pole. So if the N and N if at the time of DC excitation station, the stator, if suppose stator n pole and rotor n pole meet, then there is a repulsive force. That is that if means n and n pole dislike each other, so that rotor rejects that field is rejects this n pole. So, but if the n pole of the stator and s pole of the rotor is met, then there will be the attraction, and due to that there will be the magnetic locking between them. So rotor of this type of motor rotates as rotates at a speed which is at synchronous speed. So that's why the rotor uh, at a synchronous speed, so we call as a synchronous motor. So when three-phase supply AC sub voltage is applied to the stator winding, a rotating magnetic field is produced in the air gap. The stator field rotates at synchronous speed. The field current of the motor produces a steady state magnetic field. Field current of motor produces a steady state magnetic field. So therefore, there are two magnetic fields present in the machine, that is in stator field and in rotor field. So rotor will tend to align with the stator field just as the two bar magnets will tend to align if placed near to each other. Since the stator magnetic field is rotating, the rotor magnetic field and rotor will tend to rotate with the rotating field of the stator. So in order to develop continuous torque, the two fields must be stationary with respect to each other. This is possible and the rotor also rotates at synchronous. So basic principle of synchronous motor operation is that rotor changes the stator magnetic field. Magnetic field tends to drag the rotor along as if north pole on the stator locks in with the south pole of the rotor. So in this case, suppose this N and N unlike each other means made, then there is a repulsive rejects that, so there will be a repulsive though this rotor will not speed will rotate at different speed. But suppose s stator s pole and rotor n pole matched, then there will be the attractive force. That attractive force creates the rotor rotates the at the same speed. So let us assume that rotor is stationary. When a pair of rotating stator poles sweeps across the stationary rotor poles at synchronous speed, the stator pole will tend to rotate the rotor in one direction and then in another direction. Thus, torque acting on the rotor of synchronous motor is not unidirectional but pulsating one because of the inertia of rotor. So it will not move in any direction. So the synchronous motor has got no self-starting because there is a changes in direction of alternating current. So there is a torque production, that is pulsative torque is produced. So in order to produce the rotator synchronous speed, so we give the DC excitation at particular exact time of, that is if there is a n stator pole or else a stator pole. If there is a n stator pole, then we give a particular amount of time, we switch the magnetic field, it will create a rotor s pole. So that's why that stator n pole and rotor s pole attract each other and rotates at a synchronous. Thank you.